In this module, we'll review the Apigee Edge policies specific to mediation. Mediation covers the group of policies that interact with and have the ability to transform the request and response as your proxy executes. We'll start off with the JSON to XML and XML to JSON policies. These policies come in handy when you have a payload type mismatch between what you want to expose to the API consumer and what your target backend expects. For example, a legacy backend with XML support, but you still want to expose a JSON API. In addition to format transformation, these policies also give you control over how the payloads are converted through configuration without having to write custom code. While we're talking XML, let's have a look at our XSL transform policy. Just as you would expect from the name, the XSL transform policy allows you to apply a custom XSLT to an XML payload. This will enable you to transform XML to a different XML format, HTML, or plain text as needed. A common use case for this policy is when your API consumer and your target backend both expect XML but are using two different schemas. With this policy, you can define an XSLT to translate between the two schemas and apply that at runtime. Now, what if we wanted to go one step further and validate the XML against the schema? That takes us to our SOAP message validation policy. You can think of the SOAP message validation policy as just a message validation policy, since it isn't limited to SOAP. You can use this policy to validate XML against a schema or a SOAP message against a WSDL. It can also be used to validate that your XML or JSON is well-formed. You can use this policy anytime your consumer or target will perform schema validation and you want to avoid passing the message along, knowing it would result in an error. Next, we'll talk about two of our most commonly used policies, assign message and extract variables. You'll likely become very familiar with these two. The assign message policy is our jack of all trades. You can leverage this policy to update the request and response, as well as to set flow variables to be used later in proxy execution. One of the things I've seen this policy used for the most is HTTP headers. I recently worked on an implementation where the targets expected a set of custom headers to be added to each request, and we didn't want to expose them to the consumer, either because they impacted security in exposing sensitive data fields for specific consumers, or because we didn't want to burden the consumer with populating. In order to keep the API streamlined and easy to use, we handled this all through the Apigee standard assign message policies with conditional statements. Now, headers are just an example. This policy can be used with the query parameters, request and response payloads, the HTTP verb, and flow variables. You're also likely to leverage this policy when you are working with service callouts in order to stage the interim request and response. Now another popular policy, extract variables. You can use the extract variables policy to set a flow variable to be used later in your proxy execution. This policy is simple to use, allowing for pattern matching. The policy can extract data from the path, HTTP headers, form and query parameters, as well as the request and response payload. This is also a powerful companion to the assign message policy we just discussed. Let's say you went down the path of creating a RESTful users API where the consumer can call get users/user ID. And let's say that your target expects the user ID to be passed in a post-request body of a search endpoint. You can use the extract variables policy to extract the user ID from the URI path and then pair that with the assign message policy to both add the extracted flow variable to the payload and switch the HTTP verb to post. Next, we'll talk about a group of helper policies, starting with raise fault. The raise fault policy is used when you want to generate a fault or error from within your proxy. For example, if you wanted to return a 404 error when a call comes into your proxy that doesn't match any of your conditional flows, you can add a final flow that has a step for a raise fault policy. Within the policy, you will specify the status code and reason phrase to be returned to the consumer. Any fault that you explicitly raise will execute the fault rules, just like a standard fault raised by an Apigee policy. Now let's take a look at the access entity policy. The access entity policy allows you to retrieve metadata about your consumer at runtime. You'll be able to access data related to the developer, developer app, product, consumer ID, and company where applicable. Things like the consuming developer's email address for analytics or to send downstream to your target. If you leverage the OAuth 2.0 policies for authorization, some of this data will already be available to you as flow variables. In that case, you can leverage the access entity policy with a secondary identifier to narrow down the data returned. Since this policy will return the first match it finds, even if there are multiple matches, this can be a helpful way to drill down to a specific result. Finally, we'll cover the key value map operations policy. The KVM operations policy allows you runtime access to the key value maps that you have stored in Apigee Edge. You can store new values, access existing, or delete maps using this policy. This policy provides you with another option for situation or environment-based configuration changes without having to update and redeploy your proxies. And it can be used with both encrypted and unencrypted values. Remember that you can also interact with these values through the Apigee Edge UI and management APIs. Having an understanding of these mediation policies will go a long way towards your proxy implementations, and I encourage you to get some hands-on experience with them. If you have any questions, please ask them in our community. You can also visit our documentation site for more detailed information. Thanks.